Good day, everyone, and welcome to quarter four, week one of statistics and probability. So, for the first week, we have four modules to discuss. And to start with, we have module one, which is entitled Testing Hypotheses. And under this module, you are expected to define and illustrate the null hypothesis, alternative hypothesis, level of significance, rejection region, and types of errors in hypothesis testing. Second, identify the rejection region and non-rejection regions and the critical values. And third, differentiate type 1 and type 2 errors in claims and decisions. So for your first learning task to be accomplished for this week, we have learning task 2, which is entitled Keep Me Connected. So here's a situation where Sophia did a survey on the average daily usage of social media worldwide of her friends. So she has two claims, claim A and claim B, and these are the data that she obtained. Now you need to answer the following questions. 1. What statistical data is or are needed to prove which of Sophia's claims is accepted or rejected? Second, what is the average daily usage of social media of her friends? Compare it with the previous average usage. 3. Which of the two claims could probably be true? Why? Fourth, if Sophia computed the average daily internet usage of her friends to be higher than the global survey, do you think it would be significantly higher? 5. What is your idea of an average value being significantly higher than the global average value? And lastly, what do you think is the difference between simple comparison of data and hypothesis testing? So more or less, with the first learning task that you have to accomplish, you know our key terms for this week's discussion. Of course, it's very important for you to remember the definition of hypothesis testing and hypothesis. So when do we really use this hypothesis and hypothesis testing? So I hope you had an experience on deciding what to engage in, especially when you took STEM as your track for senior high school. And that's one way by which we can use hypothesis testing. And so, as we define hypothesis testing, it is a statistical method applied in making decisions using experimental data. Usually, this hypothesis testing is basically testing an assumption that we make about a population. And when we say hypothesis in science, hypothesis is an educated guess, right? And to further explain what this hypothesis is in statistics, it is defined as a proposed explanation, assertion, or assumption about a population parameter or about the distribution of a random variable. So let's say, for example, you have the questions like, does the mean height of grade 12 students differ from grade 11 students? Do male from do male and female from grade 11 and grade 12 students differ in height on average? Or is the proportion of senior male students' height significantly higher than that of senior female students? So those are examples of questions that you can answer through the use of hypothesis testing, or you can with the hypothesis testing. Okay. So aside from these two terms, you also need to differentiate what a null hypothesis and alternative hypothesis is. And I know you're very familiar with this. So when we say null hypothesis, it shows no significant difference between two parameters. And usually it is denoted by H sub 0, or in some other books, it's H sub 1, I think. Okay, so that's our notation. So let's say, for example, you want to state with regards to the height of male and female students of senior high school. There is no significant difference between the heights of male and female senior high school students of Quezon National High School. So that is one way by which we can state null hypothesis. And so when we say alternative hypothesis, which is just actually the opposite of null hypothesis, is the alternative hypothesis. If a null hypothesis shows no significant difference, well, this alternative hypothesis shows significant difference or differences. So usually it is denoted by H sub A. So if your null hypothesis is there is no significant difference between the heights of male and female senior high school students of Quezon National High School, well, if you will state that using alternative hypothesis, you may use three ways. Okay. One, of course, the main purpose, of course, is to show the difference, that there is a difference between the heights of male and female students. Okay. So as we move on, so let's say, for example, considering the claims of Sophia. So which of these two can be considered as null hypothesis, and which one is the alternative hypothesis? So with that, the claim A is actually an example of a null hypothesis. Why null hypothesis? Okay, look at this one. Is the same as. So meaning, there's no significant difference. Diba? You are comparing the global average usage or the population mean to that of the mean or the average daily usage of her friends. So claim A is an example already of a null hypothesis, while that of claim B is an example of an alternative hypothesis. So this is one way by which we can show that there is difference between the two. So you can use higher than. Aside from using higher than, you can also state by using less than or lower than, or simply is not the same as. Okay, so all of those are accepted as the statement of your alternative hypothesis. So aside from the first four terms that you need to remember, we also have the terms like the level of significance. So level of significance is denoted by alpha, the Greek letter, which refers to the degree of significance in which we accept or reject the null hypothesis. Okay, so it depends. So usually, so this is an example of a level of significance at 0.05. Okay, so the most commonly used level of significance are 1%, 5%, or 10%. Okay, so when we say level of significance, this will show how accurate your study is. But of course, it's not accepted that you will have a 100% acceptance of your hypothesis. Of course, it will depend. Ano po? So next word, we have one-tailed test. So one, meaning from the normal curve, there will be one-tailed. And The second one, and so we have the two-tailed test. So you will know if your test is a one-tailed test or a two-tailed test with your statement of alternative hypothesis. So if you will state your alternative hypothesis by using the words less than or greater than, then it is a one-tailed test. If you use the word less than, then the shaded region must be on the left side, meaning that will be your region, okay, your test region. And if you will use the word greater than, then your region must be on the right side of or right tail of the normal curve. But if your statement of alternative hypothesis is using the word is not equal to or is not the same as, then it's an example already of a two-tailed test. Okay, so with this one, so since we know that claim B is an example of an alternative hypothesis and Sophia used the word higher than, so that means this is an example of a one-tailed test. Okay, let's have the next words. We have the rejection or the critical region. And of course, if we have the rejection region, there must be non-rejection region. And what is this critical value that we are mentioning? Okay, so when we say critical value, it is a point or the boundary in the test distribution that is compared to the test statistic to determine if the null hypothesis would be rejected. So with our illustration, your critical value is the value by which you will have this boundary. Okay, so if it is a two-tailed test, then this will be the graph of a two-tailed test. So for the two tails of the curve, you will have the rejection region. Okay. So it's very clear that the bigger part is for the non-rejection region. So when we say non-rejection region, that is the set of all values of the test statistic that causes us to fail to reject the null hypothesis. So if you was able to compute by using any test statistic your whether to accept or to reject your null hypothesis, and if the value falls on this region, then you need to accept your null hypothesis, because this one, the non-rejection region, is also the same as the acceptance region. But if your test statistic value falls on the rejection region, okay, it means the set of values of the test statistic that causes us to reject the null hypothesis. So if it falls on this region or on the other side, it means you need to reject your null hypothesis, and all you have to do is to accept your alternative hypothesis. Okay, so let's continue. So let's say we have the given, the population mean, which is equal to 142, the sample mean, which is equal to 152, the sample standard deviation, which is 19.855, and the sample size, which is equal to 10. Okay? So with this one, we will use the t-test. Why? Because since your n is less than 30, so remember the difference between using the z-test and the t-test, that if your n is greater than or equal to 30 and the population standard deviation is given, then you need to use the z-test. Otherwise, you will use the t-test. So as for our example, we'll be using the t-test since the sample size is very small. So computing that one, okay, so this is already your test statistic, the 1.593. So you will need to locate the value of or the critical region or the critical value from the table of t-test. Okay, so what will be our degrees of freedom? So if you can still remember, during the third quarter discussion, degrees of freedom is equal to n minus 1. So since our n is 10, so 10 minus 1 is 9. So look at the part for the degrees of freedom, which is 9. That is here, 9. Okay. And using the level of significance, which is 0.05. So let us assume that the level of significance is 0.05. Then finding the intersection of 9 to that of the 0.05. So this is the 0.05 level of significance. Then your critical value is 1.833. So meaning this boundary is equal to 1.833. Okay? And since you know already the critical value, okay, and the test statistic, which is 1.593, so where are you going to locate this 1.593? Is it before the area of the boundary, which is 1.833, or beyond the 1.833? So of course, the 1.593 falls here, somewhere here, diba? So that's the 1.593. So that means your test statistic falls on the acceptance region. So which one will you accept? Of course, your alternative, no, sorry. It's the null hypothesis, meaning you need to accept your null hypothesis, whatever it is. Okay? Okay. So with the claims of Sophia, going back again to the claims of Sophia, okay? So as you can see, the computed p-value is at the non-rejection region or at the acceptance region. That means we need to accept the null hypothesis. So this one, the average daily usage is the same. So meaning the population mean and the sample mean are equal. Okay. Any question on that? So I hope none. Okay, so next terms, we have the type 1 error and the type 2 error. So what's the difference between type 1 and type 2 error? So when we say type 1 error, that is rejecting the null hypothesis when it is true with probability denoted by alpha. Okay, so in hypothesis testing, the normal curve that shows the critical region is called the alpha region. Okay, so look at this one. So this is the alpha region, while when we say type 2 error, that's the beta error, and that is accepting the null hypothesis when in fact it is false. Okay? So medyo parang nakakalito ang mga anak. Okay? So let's try to sum it up. When we say type 1 error and type 2 error, so you will base it with your null hypothesis. Okay? When your null hypothesis is true, okay, but you have to reject it, then that is a type 1 error. And your correct decision will be accepting your alternative hypothesis, though it is false. Okay? But if your null hypothesis is true and it is not rejected, then that is already your correct decision. But when we say type 2 error, your null hypothesis is false and yet you need to accept it, then we have the beta or the type 2 error. Let's have the second module for this week, which is entitled Identifying Parameters for Testing Real-Life Problems. So these are the objectives. Define parameters used in statistical analysis. And second, identify the parameter to be treated in a real-life problem. Different symbols are used to denote parameters. So remember these symbols. So for all the mean, when we say statistic, these are the values coming from the mean, from the sample, from the sample. Okay, so these are the symbols for the mean, for the variance, for the standard deviation, and for the proportion. While those data coming from the population are known as the parameters, and these are the symbols to be used. Okay, so you need to be familiar with these symbols. So let's have this example. The average height of adult Filipinos 20 years and older is 163 for, for males. Okay, so the data comes from what? Is it from the sample or from the population? Okay, so it's very obvious that when we say the average height, so meaning it's from the parameter. Okay? Yan. So the average height of adult Filipinos comes from the parameter, and our symbol is the Greek letter mu, which is equal to 163. Okay, let's have the second one. So a grade 11 researcher reported that the average allowance of senior high school students is 100. A sample of 40 students, so you have your clue already, okay, has a mean allowance of 120. At alpha equals 0.01 test, it was claimed that the students had allowance of 100 pesos. The standard deviation of the population is 50 pesos. So meaning the given, which is 100 pesos, comes from what? Yes, you're correct. From the population. Okay? So meaning our mu in number 2, so the parameter is the average allowance of senior high school students is 100. In symbols, mu equals 100. Okay. So for your learning task 3 for week 1, this is entitled Translate It. So you need to use the symbols appropriate for each given parameter. Okay? And then you need to set the value, whatever it is in given. Let's say, for example, in number 1, so we'll try to answer number 1 na ha. Average salary of Polytechnic University of the Philippines or PUP graduates is at most 324,000 pesos. So this is what? So what symbol will you use? Okay, of course, it comes from the population, so we need to use the symbol mu. And what is its value? So it's 324,000. Okay, so as simple as that. Okay, you need to follow all the rest of the given situations. And for your learning task number 4, okay, which is not recorded, of course, you may try to recall what do we mean by parameter and other things that are related to parameters. Okay, so that's all for the first part of our week 1. Okay, now let's proceed with the last 2 modules for week 2. So for week 2, as we continue with module 3, this is entitled Formulating Appropriate Null and Alternative Hypothesis on a Population Mean. Since you know already the difference between null hypothesis and alternative hypothesis, it's now time for you to formulate based on the population mean. So these are the objectives. Identify the notation to be used in formulating hypothesis. Illustrate one-tailed and two-tailed test. Differentiate null and alternative hypotheses. And formulate null and alternative hypotheses. Okay. So for your third task for this week, for learning task number 2, this is entitled Differentiate It. So here's a picture of the effects of fertilizer on plant growth. So you know what happened naman during the pandemic times, a lot of people became plantita, plantito, diba? So with that, you will try to identify the effects of on the plant without fertilizer and with fertilizer. So what do you think are the effects? And for you to clearly understand this situation, you need to answer the following questions. Okay, so you may answer the questions as briefly and as direct as you can. And so, to continue with formulating null and alternative hypothesis, let us again recall what a statistical hypothesis is. When we say statistical hypothesis, it is a statement about a parameter and deals with evaluating the value of parameter. Okay, so here's an exact, or here are the exact differences between null hypothesis and alternative hypothesis. So did you understand what it says on null hypothesis and alternative hypothesis? Okay, so let's now proceed. So this one will also help you in identifying the different symbol or in formulating your null and alternative hypothesis. Okay, so these are the steps by which you can state your null and alternative hypothesis. First, you need to identify the parameter. So what are the values given from the is it from the population, from the sample, or whatever? And from that, you may identify the claim to be tested that may show up in null or alternative hypothesis. And with that claim, you need to translate it into mathematical symbols. So aside from stating it in words, you need to state that also in symbols. So then you may now formulate your null hypothesis and alternative hypothesis. Okay, so in stating that, this is one way. Okay, so when you use the word not equal to or this symbol, so this is an example of a two-tailed test, while this one using greater than or less than symbol is an example of a two-tailed test. Okay, that's why it's very important that you must know how to translate the different symbols, mathematical symbols. So these are the different words associated with each symbol. So you have therefore equal sign is equal to, is the same as, is exactly the same as, has not changed from. If you will use not equal to, then you may use the words is not equal to, is not the same, is different from, has changed from. Okay, so you may take into consideration the different words that you may use in stating your null and alternative hypothesis. Okay, so and also remember that when you state your alternative hypothesis using greater than or less than symbol, then it is a one-tailed test or a directional test, meaning it has direction, diba? So when you say higher than or greater than, then it is to the right. When you say less than or lower than, then it is to the left. That's why it's very clear that there is a specific direction. But when we say two-tailed test, it has no direction because you do not know where to go, whether to the left or to the right of the curve. Okay. To sum what we have discussed on the different symbols and the difference between two-tailed test and one-tailed test, so these are the clear symbols to be used. Okay, so if you have the two-tailed test for your null hypothesis, we have this one. For alternative, we mainly use not equal to. But if it is a right-tailed test, then you may use equal for your null hypothesis, or you may use not or less than or equal to And then for your alternative hypothesis, it's greater than, since it's right, diba, to the right. So you should use greater than, and to the left, you have less than, okay? Let's try this given example. The average waiting time of all customers in a restaurant before being served is less than 20 minutes. Determine the hypothesis and the directional test. Okay? So you need to know first the parameter given. The average waiting time of all customers. So meaning it's from the population, right? And the parameter is average. Therefore, we will be using the symbol mu, okay? So, with our alternative, with our null hypothesis, you may state your null hypothesis, okay? So this is based on the claim, the parameter, less than. So in symbols, our null hypothesis will be, yeah, HO is equal to 20, or you may use greater than or equal to 20. And for your alternative hypothesis, it's less than. So that's one way. And that is your claim. So that is the part where you need to test it, whether it's true or not. Okay? So since it uses the symbol less than, meaning it's a one-tailed test. And to be specific, it's a left-tailed test. Okay? So it's directional. Let's have another example. Do we have another example? Let us see. Okay, so we only have one example. And to proceed with the last module, this is identifying appropriate test statistics involving population mean. And this is the part where you need to recall when to use a z-test and a t-test. And these are the objectives. Okay, so as you can see with the second objective, you know what a population variance is, if it is known or unknown, what test to be used, and still we need to incorporate the CLT or the central limit theorem. And then we need to apply those concepts in real life. Okay, so let's have the last example that we had. Okay, so a grade 11 researcher reported that the average allowance of senior high school students was more than 100. Okay, a sample of 40 students had mean allowance of 120. At alpha equals 0.01 test, it was claimed that the students had allowance of more than 100. The standard deviation of the population is 50 pesos. So these are the given, okay? Okay. And let us recall that in solving this, okay, now that you know the given, all the given, showing all the symbols to be used, we need to recall when to use the z-test and the t-test, okay? So, if the population is normally distributed, and n is greater than or equal to 30, and if the population standard deviation is known, then we will use z-test. Okay, again, if your n, or if your sample size is greater than or equal to 30, and the population standard deviation is given, then we need to use the z-test. Okay? But if your sample size is less than 30 and still it is normally distributed and the sample standard deviation is given, then we will use the t-test. Okay? But even if your n is less than 30, but the standard deviation given is from the population, then you will use the z-test and not the t-test anymore. Okay? And lastly, if your population may not be normally distributed and that your n is greater than or equal to 30, and the variance is known or maybe not known, then we will be using the z-test. Si t-test ay applicable lang if your n is less than 30 and that the standard deviation given is from the sample. Let's have this example. A study was conducted at the average time students exercise. A researcher claimed that in average, students exercise less than 15 hours per month. In a random sample size of n equals 115, it was found that the mean time students exercise is 11.3 hours per month with a standard deviation of 6.43 hours per month. So from this problem, okay, the given are your n is 115 and this is very uh, larger. Okay, it's greater than 30. Okay, and that the variance is unknown. Okay, so meaning we will be using the CLT or the central limit theorem. So we will be using the z-test. Okay, so the appropriate tool to use is the z-test. Okay, let's have the next example. An English teacher wanted to test whether the mean reading speed of students is 550 words per minute. A sample of 12 students revealed a sample mean of 540 words per minute with a standard deviation of 5 words per minute. At 0.05 level of significance, is the reading speed different from 550 words per minute? Okay, so we need to analyze. So what are those given? So your sample size is 12, right? So meaning your n is less than 30. So let's see what are given pa rin. Revealed that a sample mean and a standard deviation. So that standard deviation comes from the sample, which is 5. Okay? So that means what will be the test to be used? So we need to use the t-test. Is that clear? Okay. So I hope you were able to absorb what I'm discussing. Last example, a manufacturer claimed that the average life batteries used in their electronic games is 150 hours. It is known that the standard deviation of this type of battery is 20 hours. Consumer wished to test the manufacturer's claim and accordingly tested 100 electronic games using the battery. It was found out that the mean is equal to 144 hours. So what are given? So what is this 100? This 100 is the sample size. So that is extremely large. So meaning your n is greater than 30 and the population standard deviation is given, which is 20. So what test to be used? It's z-test. Okay? I hope that is clear, huh? Okay? And for your third task for this week, kindly answer learning task number 3, which is entitled Check It Out. You have there the direction. So again, please show everything. You may use this table for all your answers. Okay, so no need to state that in words. So you may use this table. Okay, if your n is greater than or equal to 30, then you may check this one. If the population standard deviation is given, check this one. And if that will be the case, then you have to use the z-test. Okay, so with this table, you will just put a check on it based on what are given from the problem. And last task is learning task 4. Then, of course, be sure that you take the pretest. So I hope that you will have a great day for weeks 1 and 2 of our quarter 4. Good day, everyone. Thank you so much.